is Tucker from the Math and Physics Resource Center at SVSU, and in this video we're going to go over how to subtract two rational expressions. So, moving into example 1, with these two expressions we can see that we can't subtract them quite yet because their denominators are still different. So, with these problems our main goal first is to get the denominators to be the same, and then we can subtract the numerators and simplify. So in order to make these denominators the same, first we have to figure out what the difference is between them. So we've got x and 3x. So here, if we compare these two, they're pretty similar. It's just the right term has a 3 on the front of the x. So in order to get that to be in the left term as well, we can just multiply this term by 3 over 3. Since 3 over 3 is really just equal to 1, this doesn't actually change the value of this expression. It just changes the way that it looks. So then we can actually subtract it with the other term. So if we multiply by 3 over 3, we'll just multiply across to both of these. So we end up with 6 over 3x minus 1 over 3x. Again, because we only multiplied the 3 over 3 to this term. So now that the denominators are the same, we can subtract across on the numerator. So 6 minus 1 leaves us with 5 over 3x as our final answer. Once you get to this point, usually we'll check to simplify, but since 5 can't be divided by 3, we can't simplify any more than that. So moving into example 2, once again, we have to compare the denominators. So we've got 3x and 5x squared. So when we come across something like this, what I like to do is I'll compare the numbers to each other, and I'll compare the variables to each other separately. So for the left term, we have a 3, and for the right term we have a 5. So if we want to find the least common denominator between these two, we'll just follow the same processes that we have in the previous sections. So the least common between these two is 15, and then we'll compare the variables x and x squared. So the common between these two would just be x squared, since we can multiply x times x to get it to be x squared. So here, if we put these two together, we get our least common as 15x squared. So we want both of these denominators to end up being 15x squared by the end. And now we just need to figure out what to multiply each term by in order to get the bottom to look like this. So for the right term, to get 5x squared to be 15x squared, we'll just have to multiply by 3 over 3 to change that 5 into a 15. And for 3x, we need to multiply that by 5x over 5x in order to get it to be 15x squared. So, just like the last problem, we'll just multiply across on the top and bottom for both of these terms. So we end up with 10x over 15x squared minus 12 over 15x squared. So now that the denominators are the same, we can combine the numerators. And since this term is 10x and this term is 12, we can't actually combine them. So we'll just leave them in the same numerator together. So 10x minus 12 over 15x squared. And since this can't be simplified anymore, this is our final answer. And that's about it. Thank you for watching.